Good morning. Today we are going to see parity. What is meant by parity? What are the types of parity? Okay. Here, this is a transmitter, this is a receiver. We are sending some message or data. We are sending some message or data from transmitter. For example, we are sending 1001, a 4-bit message, 4-bit data we are sending. And here in the receiving end, if you receive the same data, then there is no error. Okay, you are sending this data from the transmitter, and in receiving you have to receive the same data. If due to some noise, okay, noise means what? You are sending the data through some electrical cable. Electrical cable means lot of components are there, some messages are there. Okay, some components may leak the current. Okay, in the cable there may be some malfunction. Okay, due to that, some 1 may change to 0, 0 may change to 1. Okay, that is we are saying noise, due to noise. Okay, now this data, original data, may change into 1011. Okay, it may change like this, or it may change 1000. Okay, here what happened? This 0, that means this component, this 0 has changed. Okay, this bit 0 changed into 1, and other bits remaining same. And here this last one changed into 0. That means some 1 is changing to 0, or there is a possibility of changing 0 changing to 1. Okay, then we are getting some wrong data with error. Okay, we are not getting error free data. Now how to find out whether the data is error free or it has some error? For that only we are sending some additional bit. That bit is called parity bit. Okay, that means with normal message with data, we are sending some additional bit 1 or 0. Okay, and this bit is called parity bit. Okay, and how we are adding this 1 or 0? Okay, that is we are going to see with the table. Okay, see here I have prepared this table for 3-bit data. Okay, here data is 3-bit only, and I developed, okay, and I have written parity bit also. Okay, and we have to send these 4 bits together, and we have to find, and we have to tell we are sending some parity, and that parity is called even parity or odd parity. That means parity is divided into even parity and odd parity. Okay, then what is meant by even, what is meant by odd parity? Okay, we have to follow only one type of parity. Okay, we can follow anything, but in most of the developers, they are following even parity only. Okay, here this is the data I told you, 3-bit. 3-bit means this is the possibility. Now I have written for even parity. That means here we have to check number of ones. In even parity, we have even one, including parity bit. Okay, we have to, in even parity means we are sending the data with the parity bit also. That means all the numbers are having 0 and 1, but in that, if ones are even, then it is called even parity. Ones are even means we have to include the parity bit also, then it is called even parity. If ones are odd, parity bit, including parity bit, then it is called odd parity. Okay. Now how to decide which we have to include 0 or 1? See, here 3 zeros are there. Okay, first. Now if you include 0, then there is no 1. Okay. I told you we have to check even number only for even parity. Therefore, if it is 0, then there is no 1, that means even. And here in this data, only one is there. If you include 1, the total number will be even 1. The total number will be even 1. Therefore, now we have to include 1 here. And here 0, 1, 0. If you include 1, then only the data or the total message, okay, that is modified message, modified data will be even. Okay. And here 0, 1, 1. If you put 0 as a parity bit, then the number of ones are even. Just like you have to put parity bit. This is called even parity. And if you want to transfer odd parity, then you have to change this. That means number of ones including the modified data should be odd. Now here you have to put 1 and you have to put 0 because 3 zeros are there, and if you put 1, then only the total bit, that means modified data, will be odd. Number of ones will be odd. Here you have to put 1, you have to put 0 here, and here you have to put 1, here you have to put 0, here you have to put 1 because 1 is there. If you put 0, then only odd number of 1. Here 2 are there, that means even number. If you put third one, then it will be odd. And here also you have to put 1, and here you have to put 1. Okay. Now these are all the, here you have to put 0, here you have to put 0. Okay. Then only it will be a odd parity. This is the type of parity, even parity and odd parity. In next class, let us see how parity generator and parity checker. That means how the parity is generated in a circuit and in a transmitting end, and in receiving end how it will be checked whether we are receiving error-free data or data with error. Okay. And in this parity, it can check only one bit only. And it can check whether error is there or not. It will check only, but it cannot tell which bit is changed. Okay, it cannot tell which bit is changed. It will just tell us there is a error in the data. Okay, and it cannot tell which bit is changed. It cannot tell. In Hamming code only we can find out which bit has an error. Okay, thank you. Please put a comment if there is a doubt. Thank you.